All right, folks, remember standards work is a contributive process that we all do together, and we need volunteers to keep things moving. So it's not a whole lot of work. It's just for 1 hour. You kind of keep track of the conversation and write it down on a shared document, and Barbara will help and fill in bits if you missed. But we need someone to do this.
Hi everyone, this is Nssd, as hopefully you've gathered. So we are currently sending out a call for volunteers to write up some decisions in the notes, and we can't proceed until we get one, so please consider volunteering. We promise it won't be too difficult, and we'll be eternally grateful.
Say this is an excellent way to help you pay attention during the session. Don't know what to say.
All right, I'm going to start the slides, and we have one for the minutes, and then we'll pause there for the rest of the session until we find someone. Okay, good morning, good afternoon, good evening, good middle of the night, everyone, and welcome to DNS Service Discovery. My name is David Skenazy, and with our co-chairs Barbara Stark and Chris Box, we're going to be talking about DNS Service Discovery. Let's begin. First, the note well. So all activities during this meeting are subject to the note well. This is the last session of the week, so you've probably seen it before. But if you haven't actually read it, you should, because contributing here has various sets of rules. In particular, in terms of like if you're aware of patents, you have to disclose them. And also, this meeting is covered by the IETF Code of Conduct. If you haven't read that, I highly encourage you to. In a nutshell, it says, be nice, be kind, be professional. And anyone who doesn't follow these, whether in the chat or on the microphone or on the list, will be asked to leave. So we've never had a problem in this working group, but just want to always highlight this. Okay, so as we mentioned, we are looking for a volunteer from the audience to take minutes, and we can't start the session without one. So we're just going to sit here and stare at the empty room until someone volunteers.
So if nobody else is willing to take notes, I can at least note what people have told me, since it's great for us to me.
Yeah,
Ted, go ahead, Jonathan.
This is Jonathan. I can help take notes.
Thank you so much. That is extremely appreciated, and Barbara will be there to assist. I can take care of jabberscribing because, like with the Meet Echo chat, that is a very small responsibility anymore. And but if you want to say something and you don't want or don't have a microphone, you can say MIC, M-I-C : in the chat, and I will repeat what you said for you. All right. Here are some useful links if you're looking at the PDF later that you can click on. As a reminder, we have a working group GitHub organization. In other working groups, the switch to GitHub has been incredibly useful for tracking comments on documents. I personally really enjoy it because it's very easy with email to like forget one of the 12 comments that were sent in one email, whereas if there are issues, it's pretty clear when the issue is still open that you need to address it. We're not forcing anyone to use GitHub. It is the responsibility of the editors of a given document to choose if they want to use it or not. If they do so wish, please reach out to us and we'll help you set up and give you admin rights and everything. We have some news today. So I'd like to introduce our new co-chair, Chris Box. So thanks, Chris, for stepping up to join Nssd. Looking forward to all working together. And the sad news, unfortunately, is that Barbara is stepping down at the end of this meeting. So I would, if you're so inclined, please unmute and join me in a round of applause for Barbara's 3 years of service. Thanks so much, Barbara. It's been great co-chairing with you.
Thank you, Barbara. And hello, everyone. So yes, I'm new, but yeah, hoping to do what I can to serve the working group.
Awesome. In terms of working group adopted document status, we currently have 3 documents. So the one that we've had for the longest time is SRP. We started working group last call in July, so this one's almost done. We had a recent revision which addressed those comments a few weeks ago, and some more comments since then. So that one seems to be pretty close. We're mainly waiting on authors addressing comments to make progress on them here. We did, however, notice a bit late in the game that draft had a normative reference on an individual draft, which would block publication. So we adopted that individual draft, which is the second item here, the update lease, in September. And right now we're waiting on the editors to take into account some comments that were made during the adoption call. And then the third one is the advertising proxy document, which we adopted. We need the editors to re-upload that with the draft IETF Nssd to make it clear that it's now a working group document, and similarly to start addressing the issues that were brought up during adoption. In terms of individual drafts, we have 3 with Ted and co-authors from Apple. The first 2 at the top on replication and discovery of zones were first published like at the last meeting and a little bit discussed there. And then we have a new one that Ted just published a few weeks ago. And our agenda really flows from this list of documents. We're going to start off with the 3 that are adopted by the working group, and then with the time remaining, the 3 that are individual drafts. Would anyone like to bash this agenda? Going once, going twice. Done. All right. I'm going to stop presenting. And Ted, you're up. Please stand in the pink box. Actually, don't do the share the screen option. Go to just to the right of the join queue. You should be asked to share slides. So on the top left of your screen, you should have a join queue button, and like
there it is.
There you go. Grant preloaded slides, and then you can pick like starting off with the SRP one. Perfect.
Okay.
That uses a lot less bandwidth and gives like a really nice
Oh,
image
and I'm
quality
in
to everyone.
control.
Exactly.
Excellent.
All right.
So
here, Ted.
yeah. So basically, I think David's already pretty much summed up the current status. So we can move right on to the sleep proxy question. The issue with the sleep proxy is this is something that's it's an MDNS feature that I think at least exists in Apple's MDNS implementation, possibly in others, and it currently relies on MDNS updates. And so it seemed like it would make sense to use SRP, since SRP is a DNS update and all that. The problem is that as opposed to all of the other work that's been going on in SRP, we really haven't spent much time on the sleep proxy section of the document, and so it's not in very good shape. And that put us in the position where, I got some comments on the sleep proxy part of the document, and I basically just couldn't really address them easily. And my conclusion was, let's take this out of the document and do it in a different document so that we don't hold up the SRP work based on the sleep proxy work. Conveniently, there is already another document. So, so just a few things about this. So reasons for removing it, it's not ready to go. It's not really the same thing as SRP, although it's related. We have, we have another document we could do it in really easily. The EDNS0 owner option is basically the thing that was originally done to document the MDNS sleep proxy. So we could just shovel the section, whatever it is, into that document and advance that separately, which I think would make sense. And then let's see. Yeah, so and smaller chunks of work is good, and yeah, EDNS0 owner, like we might actually want to be able to put that into regular DNS, not just for advertising proxies. So when I hang up, that means I'm not ready to answer the phone. Not that I'm bitter. Sorry. And then, the argument against it is that there really isn't a whole lot going on the owner option right now, and I don't know if anybody's going to do this work. So if we don't do it in the SRP document, it may just not happen. I don't think that's a good argument against, but I'm open to the working group commenting on that. So basically, what does the working group think about this? Should we keep this around in SRP and delay SRP, or move it into EDNS0 owner option, or something else?
Clarifying question, Ted. In the options of what to do, you mentioned moving it to another document, and you said, luckily, we have another document. Which document were you referring to?
Well, when I say we, I mean a document has been worked on and uploaded to the tracker. It's not a working group document. That document is draft Cheshire EDNS0 owner option. And
oh, I see. And it's expired, but it could be revived, right?
Right, exactly. And I think it's we would need to revive it anyway if we were going to advance this in SRP. So it's not like, we might as well, I think we might as well shovel the work in there as well and finish that as a separate item, because then it just decouples these two pieces of work.
I think the right thing to do is to move this to another document. We might want to keep owner options separate as a small self-contained thing in its own right. Originally, Ted and I thought that SRP and sleep proxy had sufficient overlap that it made sense to discuss them in one document, because they're both using DNS updates with a lifetime to put data into some server that then does something with it. But I agree with what Ted is proposing now, which is the sleep proxy work is kind of moribund, and it's still potentially useful in the future, but tying it to the SRP document no longer makes sense. So if we want to pick that up later, we can make a new document for that. It shouldn't hold up SRP.
So it sounds like what everyone's, or the proposal is, like, leave it out of this and then bring it in another document, either revive that expired one or a separate one at some later date, if someone wants to. Is there any objection to this in the working group, or any other thoughts, by the way? All right, Ted, I think you have your answer.
Okay. And now the question is, here we go. So our next topic is the EDNS0 owner option, and I'm getting a big, oh, here we go, okay. Sorry, the EDNS0 update lease option. So this is
Yeah, there's our AD Eric in the queue.
Oh,
just want to jump in the queue. It's kind of impolite, but I just want to be sure. The previous document has been working group last called, right?
That is correct.
And isn't it such a change deserve another working group last call?
Oh, so
Oh, yeah.
we are actually, we already did that. So sorry, the sleep proxy section was removed in version 11 or 12 during working group last call. And when that version was submitted, we extended the working group last call by 2 weeks. And we are in the middle of those 2 weeks right now. So the
I should have
total.
trusted my chairs and my authors. Thank you so much, David. All is clear.
No, it's worth double checking this. And to clarify, I haven't seen any objections to the removal on the list.
Perfect.
Yeah. Kind of the whole point of bringing this up here is just to make sure that we don't, somebody doesn't miss the fact that we're talking about removing this and then later say, well, so anyway, so the EDNS 0 update lease option, this is basically just like a piece of plumbing that we need in order to get SRP to work. The problem is that, and it's sort of a general problem, it's not just SRP. When you do a DNS update, this adds an owner name and a bunch of RRs, one or more RRs to a DNS zone, and then those just kind of stay there unless somebody does something. Either the client removes it, the administrator removes it, or it just sits there. And additionally, as we all know, SRP requires a lease because we actually wanted to solve that problem, at least for SRP. But it's also the case that other DNS updates could benefit from the same functionality. SRP is a specific refinement of DNS updates specifically for doing sort of permissionless advertising using DNS updates. And so it's not the only DNS update type that exists, and we might want this for others as well. So we have this new option. It's got a lease time in it. It's actually got 2 lease times. It's got one is the lease time for the resource record that you're adding, and the other is a lease time for a key record, which you might also provide. And this is generally specific to SRP because SRP uses the key record plus SIG0 to authenticate the update. And the idea there is just that the key record is going to allow us to keep ownership of the name even if the service being advertised hasn't been renewed and therefore is assumed not to be present. So it's just a way to avoid names being sort of snarfed just as the service that was advertising the name is away from the network briefly. So so that's the basic idea. And then the document is in pretty good shape. I think David mentioned that there were some comments. I haven't actually had a chance to look at the comments, but I don't get the sense that there's anything that's likely to be a showstopper. So the question really is, right now we've got some text that talks about DNS updates, and so we've got there's some protocol along with the sort of nuts and bolts of like what the option looks like and what the pieces of it do, and that has been somewhat moribund. It's kind of in Stuart's ballpark. In Stuart's it's up to Stuart to update that in a sense, but Stuart doesn't have a lot of time for doing updates, and so it hasn't been updated. So the question is, can we do that and then finish the document? So I think the document's ready to read. My personal feeling is I'd like to make the document as lightweight as possible, but I'm curious to know what the working group thinks about that and whether we can make progress on this quickly if the working group wants to, depending on what the working group decides. So that's kind of where it's at. I guess I didn't actually put this in the slides because it didn't occur to me, but what is the question of the working group is kind of, do we want to just like cut out all of the fat and progress this quickly, or should we really get the DNS update part of this solid so that we can publish that? I don't think it's a big problem to do the second, so I'm not really advocating against that. I'm just saying, there is some additional work if we go that route.
Thanks, Ted. So if anyone has opinions on any of these questions, please come up to the microphone. Otherwise, I'm thinking of doing a poll to see like where we are in terms of having read it. Peter, go ahead.
Hello. On this option, do I understand correctly that it would also apply outside of DNS-SD situations like DHCP leases in a normal bind server or whatever?
Yeah, the idea is that if you provide a lease, you're telling the server, you know, if I want this to stay around, I'm going to renew it, so you don't have to take care of that. So it's not required. Like we're not saying all DNS updates must have this option. We're just saying if this option is present, here's what you do.
Right, and vendors of servers doing 2136 might expect this feature request at some point then.
Yes, definitely.
Okay, please let DNS op know at the right time.
Yeah.
On the last core or something.
Thank Absolutely. You. Our goal as chairs is to Our goal as chairs is to, and we had a discussion when we first adopted this document between all the chairs of the various DNS working groups and the corresponding ADs, and the conclusion was that we would adopt and progress this document in DNSSD, but that the working group last call would be sent to DNSOP. Absolutely. So that's definitely going to happen.
Perfect. Thank you.
I can just add a bit more background on this. The lease time for DNS updates is something that is, I believe, generally useful. When DNS update was originally defined, it was sort of an alternative to making edits to a zone file. So instead of editing a zone file with VI and reloading the name server, you could use the NSUpdate command, but all the edits were permanent. There was sort of an unstated assumption it was being done by a human, and what the update lease does is it makes it more suitable for machine-to-machine style communication. Just like a DHCP lease has to be renewed or it goes away automatically, it's intentionally modeled like a DHCP lease, that the client requests a lifetime, the server can grant that, or more or less. And if the client gets unceremoniously disconnected from the network, it prevents stale data from persisting indefinitely.
Quick background, Stuart. That's helpful. So it sounds, let's see. So I have a poll open. If you like, either it popped up somewhere on your screen, otherwise if you click on the show of hands tool in the top right, on whether or not people have read this draft, and I'm going to end it. It looks like we have 9 people who have read the draft, which is good. So I would say in terms of next steps, I think the responsibility right now is on the authors to address the comments that were raised during adoption, publish a new revision, mention it to the working group, and then see, we can have a discussion on there to see if folks like it. If there's not too much contention, we can then progress the document pretty quickly, move on to working group last call, which will then trigger review from various other working groups. So at that point, ideally, perhaps we have that timed so we can do a few rounds of edits and then have working group last call like during the next IETF. So that way, maybe it can be discussed at the DNSOP meeting there if the chairs over there are interested. All right. Any other thoughts from folks on the update lease document? Okay, I think, Ted, you can switch gears to advertising proxy. Yeah.
So this document hasn't actually gotten a lot of love in the last, since the last IETF. There's been a lot of implementation work on it, but we haven't had a chance to do much to update the document. So the idea is, for those who aren't aware, the advertising proxy is a way that we can do SRP updates and then advertise the result of those SRP updates using MDNS rather than using DNS. And the reason for doing that was primarily to enable stub networks to advertise services on infrastructure networks. So this stub network being like an IoT network that's just one hop away and doesn't have any transit, but just provides reachability to clients that have different, like 802.15.4 radios or something like that. And then another nice feature of this that that comes up is that it makes it possible to sort of eliminate using MDNS, but still allow, that is to say, allow a client to stop using MDNS to advertise stuff, but allow clients that do use MDNS to still discover the stuff. So those are kind of the two things the document does. It's been adopted. I haven't uploaded it yet. As I said, it's in pretty good shape, but there are some issues with name conflicts that we haven't really addressed. So in fact, you'll notice there's a new document that I'm proposing, the TSR document, which addresses some of the name conflict issues. The problem is that our model for dealing with name conflicts in MDNS is not really oriented towards proxies, and I'll talk more about that in the TSR document. But basically, we need to update this document to describe that stuff as well, so that it, you know, first of all, it needs to have a normative reference to the TSR document, and secondly, I think it needs some additional text to talk about how to deal with conflicts generally. So so I think it needs some more work, you know, I would not encourage people to read the document yet, because I think that we need to do an update, and then once that update is done, I'd really appreciate some reads and reviews.
Thank you, Ted. I'm going to similarly do a poll just to get a feel for who's read it. Oh, well, I guess I forgot to put a title, sorry. So this one is, have you read this document? I don't know where that window went, but you can raise hand to say you've read this one, or not raise. While we're doing that, if anyone has any questions, comments on this document, please join the mic line. All right, cool. So we have 7 folks who've read it. Nice. Esko, go ahead.
Yeah, I did send my comments by email, so I'm not sure if I'm supposed to reiterate them here. I'm not sure if Ted has had the time even to check out these most recent comments.
I don't think I did. I'll double check, but yeah, I don't think we really need to work on it here. We don't have a lot of time, so it's probably not worth going into it in detail here. But I'll take a look at your comments, and as I said, I'm going to update a new document. So so that would be the time to review and see if I missed something or dealt with the issues you raised.
Yeah, I think the main point was that I think one section really needs to be simplified in some way, and maybe some other people can also have a look at it, see if that can be done. Because it looks to me like it's almost too complex to just parse when you casually read it. Maybe the implementers don't have a problem with it, but yeah, for other audience, it should also be clear enough, simple enough, I think. But that's the main comment I had. For the rest, looks good.
Thank you for that, Esko. So I think in terms of next steps here, Ted, you have some edits that you want to make to the doc, and then we have some comments from Esko that need to be addressed. So action item is on you to have those, submit a revision of the draft, and then let the mailing list know so we can have people review that revised version.
Yep.
Okay. Unless we have something else on this document, I think we can move on to the next one. So these, yeah, we're transitioning from the working group documents, current work, to individual drafts, future work. What I'm noticing here, though, is that a lot, like all the action items appear to be on you, Ted. So maybe from a chair's perspective, I mean, let's discuss this new work. That's good, but I think we should probably focus on the existing work and getting that out the door before we add more things to our plate.
Fair enough. Yeah. I will say that I have gotten some offers. There, one of the other implementers of this protocol, who is here in the room today, I'm not going to mention his name, but he can mention his name if he wants. has offered to help out, and with the replication protocol document, and so I'm thinking that it would be nice to add him as a co-author, and that would potentially reduce the workload on me, and that would be good, whether we adopt it immediately or not. But basically, I just want people to be aware of this and thinking about it, and maybe even trying an implementation or criticizing it, because I'll get to the end of the document and then talk about this. So I wanted to just
sounds good. Just to answer to that quickly. I think that's a great idea, because I think you're pretty, and both Stuart and you are bandwidth limited these days, which I totally understand. We all have day jobs, and so adding a co-author before asking for adoption sounds like a great idea. It'll definitely give us more confidence that the document will be worked on. So that sounds absolutely great. Thanks. All right, go ahead.
Sure. So I just wanted to give a quick overview of what's going on here, because there's a lot of stuff in Fly. Obviously DNSSD has been working on DNSSD generally for quite a while. We have MDNS. We've had that since before the working group started. DNSSD on DNS we had. These are all in the base documents, 6762 and 6763. The working group produced the discovery proxy document, which allows us to use DNS to do MDNS discovery on a link. And then SRP, which we're almost done with, lets us register services with an authoritative server. And the advertising proxy lets us advertise services from that authoritative server using MDNS. So that's kind of the stuff that we're already working on. And most of that stuff is fairly mature, and we should be able to shove it out the door pretty quickly. Then there's SRP replication. SRP replication addresses the problem that when I started doing the SRP work, I was just assuming that we were updating like bind 9 or something like that. I wasn't really thinking about it in terms of home networks. So SRP assumes an authoritative server, but that turns out not to be a very realistic assumption on a home network. On a home network, the home router is usually some little box that they were trying to reduce the materials cost to the lowest possible amount. So they put in less memory, less flash, everything. So having that act as a resource for doing service registration turns out not to be. It just doesn't work right now. That could change. We'd like that to change, but that's the way it is right now. And so the existing implementations of SRP that are out there in the world are actually devices that are SRP plus advertising proxy. And wouldn't it be nice to be able to have sort of the reliability of a managed DNS server without a manager? And so SRP replication allows a bunch of devices, a bunch of SRP / advertising proxy servers to collaborate in producing that reasonably stable namespace without there being an operator. So like you could have, for example, like a couple of HomePod minis. Each one of those has an SRP server. Each one of them is doing SRP replication. If any one of them gets an update, all of the other ones get that update. It's really nice. So that's kind of the goal of SRP replication, is just to like fill that box in the block diagram with something that doesn't have to be managed by a network administrator. And then the other work that I'm going to be talking about, permissionless advertising of DNS zones, is basically once you have that stable DNS server, or reasonably stable DNS server, wouldn't it be nice to be able to just query it using DNS or DNS push rather than multicast DNS? You can eliminate some of the DNS. So basically what this allows us to do is, the permissionless advertising work is going to allow us to do is to allow DNSSD clients to query SRP. They can basically discover the SRP server and then start using it as an SRP server, as a DNS server, rather than using the advertising proxy way of talking to it. And similarly, if your infrastructure supports delegating DNS zones, then we have a way to advertise a discovery proxy or to advertise an SRP server into the infrastructure in a way that just cleanly, works, and then we can actually eliminate MDNS entirely. And still get all of the functionality that we currently get with MDNS. We get the support for service discovery. We get immediate, like we can have an ongoing query and get immediate results because we have DNS push. So it basically gives us all of the stuff we're used to with MDNS without any multicast. Back to SRP replication. The first question is, why do we need a new protocol? And the problem is, like, my initial thought was to use DNS and IXFR, but I couldn't actually come up with a way to do it that I could figure out how to implement and that I thought was going to work well. We have this problem that DNS expects there to be a primary, and the primary replicates everything to the secondaries, but we can't assume that any one of the servers in an SRP cloud is stable. So it might go away at any time. So that means that when it goes away, we have to pick a different primary, and we have to figure out if the data that server has is correct. And it just becomes like this big, challenging problem. And the biggest problem is we don't actually have a way to establish trust. So the only real trust that we have is that when we get an SRP update, that update was signed by the client. And so we know if we get another update for the same name, we can tell if it came from the same client. And so I kind of wanted to leverage that source of truth for SRP replication. And that meant that I couldn't just, we couldn't just have a zone, because the zone doesn't have the information that we'd need to actually validate that that a new change to the database actually came from an SRP client. It didn't just come from a rogue SRP replication server. So that's kind of why I invented a new protocol. Sorry. So the new protocol, the idea is that there's an arbitrary number of SRP replication peers which can come and go. We could limit the number if we wanted to, and I think that might make sense, but I don't know what the limit would be. There is no authority. We're trying to maintain a common data set. All of the servers are communicating. They're all peers, but we do have a precedence because we've got to figure out some way to decide who talks to whom. We have a database sync and reconciliation process, and then whenever something changes, we replicate those updates to all of the other servers. So the way this works is that, so we're assuming that the SRP client is only going to update one server. So there's going to be some advertisements for servers. The client's going to pick a server. It's going to advertise to that server. We can identify the client using crypto because it has a public key. So we know if we get an update, we know that it's from the same client or that it's not from the same client for any given host record. And we know when we got the update. So if a client sends an update, it's either newer than what we have or it's older than what we have. But if we receive an SRP update, it's always going to be newer than what we have. So essentially, the client winds up being the authoritative server for its data. And we just maintain this data set. We try to keep the data set in sync. It's not a catastrophe if it's not in sync. The worst case scenario, if we totally lose a client update, is that we'll get that information the next time the client renews. So it's as stable as it needs to be for what we're trying to do. It's not perfect, but it doesn't have to be perfect. So what we're replicating is the data, but we actually replicate the SRP updates, not the data. The SRP updates are then applied to our local version of the database, and that winds up replicating the data. But because we're replicating the updates, we can validate them. You guys can read the slide again later if you want to get more details, but that's the basic idea. So the flow of the protocol is that first, when an SRP server comes online, it needs to figure out what data set it's replicating. And that's somewhat situationally dependent, and there's some language in the document that talks about how to do that, but it may be implementation dependent. We can't necessarily specify it in full detail. or there may be sort of documents that specify, like if you're trying to do SRP replication in this situation, this is what it looks like. So in other words, for example, the stub networks document is probably going to have some text about that. So we choose a data set, we try to find SRP replication peers that are replicating that data set. And if we find them, then we just join in. If we don't, then we become the first and we start advertising. And that's pretty much it. So then the next step in the protocol is connecting and reconciliation. So we connect to a peer, and then we compare our databases. What we're looking for is if the peer has newer data than we have, then we want the newer data. And if we have newer data than the peer has, then we want to give that newer data to the peer. And so that means even if we got some updates before reconciliation occurred, we can still reconcile them. And we can feel secure that it's actually going to be correct because because we're passing around the actual updates, including the time at which the update occurred, which lets us validate it. So and the other thing is, it's possible that an SRP replication peer might have gotten an update, replicated it around, and then gone offline. And so during the reconciliation process, those updates are still going to be part of the reconciliation process, even though they weren't received by the server that's offering them, because we want to make sure that we replicate the whole database, even if the server that originally got the information is gone. So, and then once we're up to date, then whenever a peer gets an update, it just sends it to the other peers. And whenever, so from the perspective of an individual peer, it's sending updates whenever it gets an update, and occasionally it receives updates from other peers. We don't expect this to happen a lot, but happens from time to time. And during this period, we don't do secondhand updates because at this point, these are live updates. So if something goes wrong in this process, it's basically going to have to be resolved at the SRP level, not at the replication level. But generally speaking, it's, usually stuff won't go wrong in this situation. So that's the basic protocol. Current status is we have 2 implementations. There's an implementation if you have tvOS 15, which is the current release, that has this code running in it. Slightly different version than what's documented, but that's sort of par for the course when you're inventing new protocols. OpenThread has done an implementation. I haven't looked at the implementation yet, but I've had some conversations with the implementers, and it sounds like they're doing a great job, and I'm looking forward to us doing some interop at some point. So so basically, I don't know if I put it, no, so basically my goal is to ultimately get this work adopted by the working group. This is probably the biggest ask that I'm ever going to make of this working group, because this is a fairly complicated spec. I think the people who are interested in this are more likely to show up here than somewhere else. So I think this is the place to do the work. David made the good point that we don't want to overload the working group given how many people are participating. But this is, to me, it seems clear this is the place to do the work. So basically, this is kind of your fair warning that I'm going to be asking for adoption at some point. If I thought David wouldn't laugh at me, I would ask for adoption now, but he'll probably laugh at me. So that's where we are.
So any thoughts from the working group? Just join the queue if you do, or type in the chat.
I'm going to thank Ted for bringing this introduction to the group. And I'm also going to suggest, in the interest of time, that we move on, because we just have 15 minutes left. And I think 2 more topics to cover.
Yep. Yeah, we don't have to make a decision right now.
That sounds good. From the chair's perspective, I'd say, yeah, let's, if you could prioritize going through the action items you have on the adopted working group drafts, and those look like they're no longer blocked on you and making good progress, then I think, then and taking a co-author, then bringing this back, I think there should be appetite at that point, as long as we, as long as my only concern is I want to make sure that this new work doesn't delay the existing work. But as long as it doesn't do that, assuming there are multiple folks from different affiliations that are interested, then we can definitely consider adopting this. I'll double check the charter, but I'm not yet worried. I'll double check that with our ID and everything.
Okay, cool. All right. So let's see. I think the next on the agenda is the discovering DNS zones. So actually, it's discovering and advertising DNS zones. So kind of a crapshoot. What lands in the title? So this is some work that I've been working on with another colleague, and there's actually an implementation of this in the latest version of tvOS as well. The problem is that so our goal here is to be able to discover a lot of services on, and these would be like IoT devices, so like light bulbs and outlets and sensors and stuff like that. You can have quite a few of those on a network. The original model of MDNS was you were going to discover printers or something like that, and usually you don't have like 1,000 printers, or I mean you probably don't have 1,000 light bulbs, but usually you don't have even 50 printers. You have like maybe 2 or 3, and with IoT, you really could have like 50 or 100 devices, and now you do an MDNS query and you're getting back a lot of answers, and so that's a lot of stuff to be putting on multicast. And so that's one problem, is the amount of stuff. The other problem is that there are devices that like to go to sleep, and for them to notice, to have a complete set of data about what's going on in MDNS, they have to be either listening all the time, or they have to like do a point query. But even then, there's no guarantee they're going to get all the data. And so being able to have a TCP connection that is open and doing DNS push is a lot cleaner solution to both of these issues. And so what we propose to do, the problem is, of course, what we'd like is to be able to just advertise this stuff to the infrastructure, have the infrastructure pick it up, delegate the domain, and then have all of the discovery stuff sort of work. And that's certainly our end goal. But in the meantime, we also need to be able to have this stuff work even if the infrastructure doesn't support it, which at the moment it definitely doesn't. So the way to do that is to advertise the zone using MDNS. So essentially, or and by extension, Nssd. So we're still using MDNS, but we're only doing 1 query instead of 50. So it's a big improvement. And also, like if you're using a device that sleeps a lot, your iPhone or your watch, or I'm sure there are equivalent products from other companies, then DNS push is a much it's much easier to make that work. Even if you have to reestablish a connection every time you wake up, you can get a complete list of all of the data that you want to know about very easily. But ideally, the connection just survives your sleeps, because you're sleeping momentarily, right? You're like sleeping for a second at a time and waking up every second or something like that. And so when there's an update, you'll just get it as soon as you reconnect, and the Wi-Fi base station will probably have remembered it for you. So the way this works is we have to choose a name that won't appear, that's never going to appear in the DNS. So we actually need to create a new name, like home.arpa, but something that's specifically for this purpose. Yes.
Ted, let me just add something which I don't think you actually said. Mm-hmm. The idea here is that instead of multicasting a query to every device on the network, the client that wants to do discovery talks to a server using unicast, which is much more efficient on Wi-Fi. And the bootstrapping issue is, how does it figure out what entity on the network is the unicast server it should be talking to?
Yeah, or to put it slightly differently, what entities on the network are available that can act as that unicast server, because there might be more than one.
Yep.
So anyway, the idea is we don't want to create a security vulnerability here by allowing arbitrary devices on your network to use MDNS to override your DNS configuration. So therefore, we'll allocate a zone that's only for this purpose. And so it'll just be devices that are doing the same thing, competing with each other. And if one of them is malicious, that's not great, but at least it's not going to be able to do a man-in-the-middle attack on your bank transaction or something like that. And then basically the idea is you advertise data sets that you have. So you might have an SRP database data set if you're doing SRP replication. You might have one or more discovery proxy links. And so if you have any of those, you just advertise them with MDNS. The client goes out and tries to find the list of zones that have data sets it cares about. And then so when a DNSSD query comes in that doesn't specify what domain to look in, you know, sometimes the query will specify look in .local, and then you only look with MDNS. But if the query doesn't specify a particular domain, then we're going to set up the browsing domains so that these zones that we've discovered are browsing domains. And so we'll now do DNS push queries to get answers in those domains. And so and the idea is that any server that's advertising a particular data set should work. So data set could be an SRP replication data set, or data set could be a discovery proxy link. And in both of those cases, SRP replication gives you a uniform data set, whichever server you talk to, and discovery proxy gives you a uniform data set because you're using MDNS on a particular link. And so any MDNS client on a particular link is going to see the same information. So it doesn't matter which server you connect to in either of these cases. So current status, there's an implementation in tvOS. The current implementation is not doing exactly what I think we should do. It's using NS records and advertising legacy browsing domains, and it only works with MDNS. And after having played with that for a while, I came to the conclusion that we probably wanted to just advertise this as a service. So the service will say, "Hi, I'm a service that does, you can use to do DNS push, and here are the databases that I replicate, and or here are the data sets that you can query," and then just kind of have the plumbing be done based on that. So and then also an additional service that could be advertised is discovery proxy for this link. So now, if you have a sleepy device, it can just connect to the discovery proxy for this link and get the same information that it would get if it were doing MDNS itself, except without having to be awake all the time. So that's where we are. The request of the working group is, please take a look at this, comment on it, and again, at some point, I'd like to recommend this for adoption. So that's that.
Does anyone have questions or comments on this document? Please join the mic line now. Otherwise, I think in terms of conclusion, kind of similar to the previous draft, if we, looks like we're making good progress on the existing work, and potentially I would encourage you to find a co-author with a different affiliation on this one as well. I think that'd be helpful. It sounds like, you're using this for your Matter technology. Is that correct? Or so?
Sure.
Okay. Well, if this is being used by, for us to want to adopt this, the implication would be that it's a general purpose specification that anyone.
Yeah. So, and that's the intention. My goal here is actually so remember, I was trying to do the HomeNet naming architecture back in the day, and that basically failed because we tried to bite off too big a chunk at once. So what I'm trying to do is address each of the things that we want the HomeNet naming architecture to do piecemeal. So you could say, well, it's a matter specific thing, but no, it's not. The idea is to fill in all of those little building blocks so that then we get to the point where we actually can have what we were trying to do in the beginning with the naming architecture. So it's more that I'm using Matter as an excuse to succeed in this hobby than it is the opposite. But
that makes perfect sense. I'm just saying, for us to adopt this, the goal would be to have interest from various folks. If it's just a protocol between an iPhone and an Apple TV, then you don't need a working group document.
Obviously.
Yeah, that makes sense. David, let me answer your question. Actually, I want to start off by thanking Ted for the enormous amount of work he's done, both on coding and debugging and writing the documents too. I also want to thank Chris Box for stepping up as our new co-chair. The reason Ted has been working so hard is because there is a lot of use for this, and there's lots of activity going on outside the IETF. And we are trying to encourage those people to engage with the IETF. One thing that some people in this group know about, but many will not, is the work going on with Thread. Thread's a 1/4 megabit wireless mesh technology for home devices like light switches and motion sensors and thermostats. And on that network, Thread is using SRP to reduce the reliance on multicast, which we know works very poorly on wireless networks. Thread is being used by Matter, which used to go by the working title Project Chip, Connected Home over IP. And that work is done by the CSA, the Connectivity Standards Alliance, which also changed its name. That used to be the Zigbee Alliance, and it changed its name recently to reflect its new focus on IP technologies. So Matter will be using Thread as one of its lower layers. It's also using Wi-Fi. People in Matter are looking at the work done on Thread using unicast discovery to make it more reliable and less expensive on the network. And there's now been discussions about we should do the same for Wi-Fi. Wi-Fi access points should all have SRP servers in them. So I'm not pre-announcing anything there because this is a long way from being done, but there's already discussions going on there that Matter would like to see Wi-Fi doing SRP just like Thread is. So there's a ton of stuff, and this is what is keeping Ted busy with so many groups interested in this. And I'm mentioning this because all of that is largely invisible in the IETF to people who are not involved with those groups. And we are actively trying to educate those people about IETF and explain to them how they can participate.
Thanks for the background, Stuart, and thanks for doing that work. I think having a fresh set of new eyes and new ideas in the working group is always a good thing. So that's what we're looking for in terms of bringing new work. Great. All right. So Ted, you have your last document. We have 4 minutes left, and I want to keep one for the chairs. So if you could just zoom through it, please. Go ahead.
Yep, I will do my best. So the issue is that we have a problem when we have SRP replication or when we have independent advertising proxies, which is that we can get conflicts, even though what's actually happened is a legitimate update. MDNS assumes that if something has registered a service and something else comes along and tries to register a service under the same name, that the something else is the interloper and should be rejected, and the original should stay. But with a proxy, the new update is we're able to validate with SRP that it came from the same device. So it's not an interloper, it's the same device, but we still get a conflict. And so the idea is, in the case of proxies, to have a resource record that's MDNS specific, that just says when we got the update. So that if we get, so when we send an MDNS probe, we include that information, and then an MDNS server that has that's doing the same thing sees that probe and sees that there's a conflict, but that the new information is that the information being advertised is newer, then it's going to not report a conflict because the information is newer, and so it'll ultimately just drop the information, the stale information that it has, and allow the new information to be advertised. And with SRP replication, of course, ultimately both of them will wind up advertising the same information. But this just prevents all of these messy conflicts that can occur and the renamings that can occur. So as requested, I don't think there's a reason to go into too much more detail about that. The slides are up on the server. And of course, you can read the document, which I think explains the situation pretty well. So the request to the working group is to take a look at this. It's pretty simple. I think it's pretty necessary for the advertising proxy work. So I think we want to include this in the advertising proxy work. But I don't think this is a really big task for the working group. I mean, I wrote this up in an hour, and I'm sure that it can use some review, but I think it's pretty solid. So so that's where we are, and you have a minute.
All right. Thank you, Ted. We're going to take questions on this specific presentation to the list. Boop. And then put these back. There, done. All right, so and I think same kind of conclusion as the other ones, Ted. This looks interesting. It appears to be in scope, especially if in the context of advertising proxy, if the working group thinks that advertising proxy should have a dependency on this, that'll help motivate and bring it in. But similar to the previous ones, we want to see progress on the other drafts, and we would love to see some co-authorship with diversity of affiliation. All right, thanks everyone for joining our DNSSD session, and this great IETF week now comes to an end. We're all going to be able to sleep. It's going to be amazing. And as parting words, see you all on the list, and thanks so much, Barbara, for everything. We're going to miss you here, and I hope you still show up, even if you're not at the chair table.
Yeah,
Thanks,
thank you, Barbara.
everybody.
Thank you, Barbara.
Bye, everyone.
Thank you. Yeah, please keep coming. We'd love to see you.